Good afternoon, Professor and everyone. My name is Masa. I'm from Sunshine University, from the Department of Software Conversion Department and Mobile Computing and Networking Lab, under supervision of Professor Kim Sakun. Today, I would like to present my projects in title of Intelligent Resource Offloading Scheme for Enhancing Reliable Hospital Big Data Communication. This project's purpose is to overcome the quality of the bits of big data health system in terms of the end-to-end communication reliability and reduce the end-to-end communication time. So we will go through its contents. So first, start with the introduction of big data in hospital. As shown in this figure, the figure presents the overall big data system in hospital communications, in a smart hospital communications. That there are 3 layers, including healthcare Internet of Things layer. That this layer is mainly focused on the physical based layer, or that located in the user side. This layer will be a convergence of the various health Internet of Things, including wireless sensor network, but body area network, and wireless body area networking. This health Internet of Things sensor will be attached to the human body to sense information, specific health status of the user health, and send the information to the hospital cloud in order to perform processing in a specific purpose. So in smart health system, the real-time evaluation of the human health will be required to perform. So there are many entities have to be considered in the user side. To send the real-time information to the hospital data center, and the experience or the previous information of the human health has to be stored in order to keep track of the human health status. So in the local cloud or hospital cloud will be faced with the big data environments, because of the information will be keep increasing. So there are many requirements and challenging issues in this smart health system. So as shown in this figure, I comprise the healthcare system into 4 sub-base layer: the user layer, a signal layer, data network layer, and data processing layer. So to perform to certify the quality of the bits of the healthcare system, it is especially in big data perspective. So the reliability is very critical. The key have to be performed, and computing time, or we call end-to-end computing time, to perform the real-time analytic, and some of the almost healthcare information will be sent through the through the live edge Internet of Things, Internet of Things device, that have to be have to be considered on the reliability transmission. That the live edge sensor will suffer from the communications tracking, handshake, or reliable protocol. So in this scenario, it is very critical to handle to ensure the end-to-end transmission reliability. So this, to meet the perspective of the big data computing environments, we have to prevent this. We have to face with this challenging issue. In the users layer, there are heterogeneous of the slide or Internet of Things. So it's required to perform slicing of different of the sensor or network body area network service in different of the based on different service computing requirement or results. And in the user side, we have to increase the availability and power savings. At the sync node, in the sync node layer, this layer is the the communication between user layer and single layer is checking of the quality of the service class identifier in order to avert the specific of the health information, and the communication delay between the scheduling radio network to the optical network interface will be happen. So the require of the optimal mix scheduling algorithm will be mandatory, and algorithm and affection handle of the signal resources, and to improve the communication reliability and reduce the request drop ratio at the of front core interface or single layer. Network layer will have to face with variety of the communication traffic of the human of the health Internet of Things traffic. So in this place required to provide the intelligent traffic steering and deep packet awareness in order to identify the different of the level of the traffic have to be performed with different of quality of service handling. And at the data processing is required for rapid processing time and certify accuracy of decision, and can work well with the scalability, because in this place have to the data science will be scaled, will be big. So it requires real-time operation method to perform the real-time operation and service availability, perform the service availability. So in these projects, we will focus on the signal layer and data network layer. So we will perform optimal signal selections in order to adjust the incoming request to join the radio resource between send information to the hospital cloud. So we provide the channel handlings, optimal channel handling to reduce the loading time in the max scheduling area, and adjust the uplink and downlink resource, and slide the distance of the signal due to the different of signal. We have different of the status condition, resource status, and to prevent the failure of the signal gateway. So it have to be slicing it into differently, and perform the optimal select, adjust the traffic according to its status. And at the data network layer, it is very important to perform deep packet inspection, because we have to provide the effective handling based on different of the packet status. I refer to the packet status is referring to the different class of the healthcare informations, healthcare traffics, and monitoring the each of the data plans network status to inspect, to find out the vulnerability of the network failure, and we try to it is possible to prevent the failure of the network, and perform the intelligent traffic steering based on the different slide, different aspects according to the obviously status of the data plan network gateway. So all of this can be done by using artificial intelligence, software-defined network, mobile computing, network function visualization, and network slicing technology. So this technology will be a converge using in this project. Of the method is we have to classify the data plans, all data plans resource, including the incoming traffics, incoming of the healthcare traffics, and signals, and gateway to the edge cloud or hospital cloud, in order to perform different of to perform network slicing different according to the different of the existing resource of the different entity. It is very important to perform real-time classifications based on its obviously status. So in order to perform classification, we will apply variety of the library machine learning Live machine learning will be used because of it's required a short period of time, short period of computing time. So we will select the best the optimal one with the which perform high accuracy and certified for the real-time network environment. Traffic slicing after classification, after performing the classification of the data plan traffic, the second step is have to recommend each of the resource, the optimal resource to serve the different slice of the traffic and stay in the radio or network in the sync node, and from the sync node to the edge cloud or hospital cloud gateway, it required to perform the recommendations to select the appropriate gateway for handling based on the gateway status. So in the recommendation system will be used based on the live machine learning. So end-to-end network slicing will be performed as shown in this figure. So by applying the several mentioned key technology, the proposed method will enhance the significant quality of service in hospital big data system as follows. So end-to-end network slicing based on this distinct resource service requirement, intelligent service handling for each slide of the health Internet of Things, and effective handling of health Internet of Things traffic and bandwidth utilization, reduce the energy consumption of the health Internet of Things sensor and device, and perform ultra low end-to-end latency and enhance response time, and perform ultra high communication reliability. So it is very important to handle the end-to-end communication traffic to meet the perspective of the big data computing purpose. So these projects will handle the significant issue and suitable for future smart healthcare system, especially to guarantee end-to-end quality of service of the hospital big data network environments. Thank you very much.